Good evening, everybody. This is Pawan Kumar, faculty at ESE Engineering Academy, and today we are going to discuss one of the important concept with respect to the GATE examination and ESE examination also. So today I am going to discuss about the topic known as pile foundations. Yesterday evening 6 to 7 p.m. in that session I have explained you what is the syllabus, what are the inclusions, exclusions, what are the topics that you need to be covered, and from what topics you will get the major amount of the marks from Geo-Technical engineering. I have explained you in yesterday's session. Right. Today we'll take one concept and we'll try to solve or 2 or 3 questions based on that concept. I don't want to go too much explicitly. I will go what is that concept, what is the requirement of that concept, and how you are going to apply that concept in the case of the examination. So now what I want to explain over here is, in the case of the pile foundations, we know the pile foundations is one of the deep foundation where the load carrying capacity of that pile depends upon the resistance offered by the soil at the pile tip and the frictional resistance developed along the surface area of the pile. So how to determine the ultimate load carrying capacity? So that's what I am going to discuss. So determination of ultimate load carrying capacity, QU. You can do it either by means of static formulae, or you can also find it out by means of dynamic formulae, and you can also do it by means of the pile load test. Out of all these methods, the most appropriate way to determine the ultimate load carrying capacity is pile load test. But anyways, that is an experimental procedure. But in examination, majority of the questions will be getting from the static formulae. Okay. So if you see the static formulae, and in the case of the static formulae, you take any pile, whether it is a driven pile or a bored pile. A pile can be installed into the soil either by driving through the pile driving equipment or by drilling a borehole. Later, that borehole is filled with concrete and steel. Okay, so this is a pile which we have installed in the ground level. So if you observe here, so whatever the load that we apply, the maximum load the pile can carry depends upon the resistance offered by the soil at the base, that is the base resistance, or point bearing resistance, and resistance offered by the soil at the sides, which is nothing but QS, skin frictional resistance. Okay, so where the ultimate load carrying capacity is nothing but the point bearing resistance QB plus skin frictional resistance as a QS. But in order to find out that point bearing resistance and skin friction resistance, we convert them in terms of the pressure. The point bearing resistance is all about what is the bearing capacity of the soil at the pile tip. What is the bearing capacity of the soil at the pile tip? So this QB is small QB, which is a bearing capacity, into area at the base plus small QS, which is a frictional resistance, into surface area AS. If you take L is the length of the pile which is embedded into the soil, if L is the embedment length of the pile, L is embedded length of pile, L is embedded length of pile, and D is dia of pile, whereas D is the dia of the pile. Now the base area, it's just like, you see this is a water bottle, and this water bottle is just look like a circular pile. If this is the L is the length of the pile, and you can see this pile, whatever the circular cross section, right? So at the base there is a base resistance, and that base resistance is due to the bearing capacity acting at the pile tip. And what is the cross section of the pile tip? Circle. And what is the area at the pile tip? Pi by 4 d square. Similarly, the skin friction act all along the surface area, right? So then what is the surface area of this pile? Perimeter into length. So now if you observe, the area at a base AB is equals to pi by 4 d square, and AS is nothing but the surface area, which is nothing but pi dl. And where this QB is nothing but bearing capacity. Where QB is nothing but bearing capacity. And QS is nothing but skin frictional resistance. Skin frictional resistance. Okay. So that is nothing but the bearing capacity, and other one is the frictional resistance or skin frictional resistance. And this QB and QS depends upon the type of the soil. So if the soil is clay, now have a look. If the soil is a clay soil, in the case of the clay soil, for the same pile, let's say this is the pile, and the pile is being installed into a soil, and I need to find out the ultimate load carrying capacity. See, the clay, it can be a homogeneous soil or it can be a anisotropic soil also. Suppose if I take a layered deposit somewhere like this, in this above the undrained shear strength or cohesion is C1 and here it is C2. Let's take this length as L1 and this is L2, the portion of the pile where it has been embedded. Let's take the total length as L. Now there is some base resistance at the sides and there is some skin friction, base resistance at the bottom and skin friction at the sides. So now it all depends upon the bearing capacity. What is this bearing capacity? Actually, if you see the bearing capacity, either from the Terzaghi or Meyerhof you can take. In bearing capacity equation, the bearing capacity equation goes as CNC plus gamma D NQ plus 0.5 gamma B and gamma, right? Here B represents the dia of the pile. Here B represents the dia of the pile. Here B represents the dia of the pile. This represents the dia of the pile. And D represents the length of the pile. Now, if you see in the case of the deep foundations, the dia of the pile is very less. In shallow foundation, width is more. In pile foundation, the width means diameter is very less. We are going to neglect that term. In deep foundations, if you observe, the length is very much greater than the width, which means whatever the length is much greater than the D, you can neglect the width effect. If you neglect the width effect, then QB is equals to CNC plus, I'll be taking the gamma into L as a vertical stress into NQ. And now this is the ultimate bearing capacity. So QB is nothing but the bearing capacity, ultimate bearing capacity in deep foundations, as the width is very less. Width is nothing but dia of the pile is very less. Neglect that width effect. So, and if I take a clays, in clays, the CNC is much greater than the sigma V dash into NQ. Because in the case of the clays, the NQ value is very less. NC value is more. In clays, NC value is more, NQ value is very less. And in the case of the clays, the ultimate bearing capacity is simply CNC. The ultimate bearing capacity is simply CNC, right? So in the case of the deep foundations, basically you neglect the width effect. Then there are only two effects, which is nothing but the cohesion effect, and this is the vertical stress effect. We don't call it as a surcharge effect over here. In clays, NC value is much greater than the NQ value. NC value is much greater than the NQ value. Due to NC value is much greater than, CNC is much greater than the vertical stress into NQ. You know, NC and NQ, they are the bearing capacity factors that depends upon the phi. NC and NQ depends upon angle of internal friction phi. In case of the case that NC is equals to 9. In examination, especially in gate examination, they will mention mostly. If they don't mention also, you take the NC value as directly 9. There is no ambiguity in that. Simply, you can write the QB as 9C. And what is this C, sir? That C is nothing but cohesion at the pile tip. The C is nothing but cohesion at pile tip. Okay. Whatever the C, that is nothing but the cohesion at the pile tip. So, if you observe, whatever the cohesion at the pile tip, that is known as, in the case of this example, the cohesion at the pile tip is C2. So, in simple, QB is equals to CNC. In simple, QB is equals to CNC, right? Yeah, good evening everybody. Okay. So, in simple, in the deep foundations, if you observe, QB is equals to CNC for the clays. And now, if you look into the skin friction, in the case of the clays, the skin friction is equals to, in the case of the clays, again, the skin friction over here, if you observe, the skin friction is alpha into C bar. Alpha into C bar. Alpha into C bar. So, if you observe over here, again, in the case of the alpha. So, where alpha is known as adhesion factor or shear mobilization factor. That again depends upon type of the clay, whether it is a stiff clay or soft clay. So, adhesion in the soft clay is more than the adhesion in the stiff clay. And C bar is average cohesion along the length. Average cohesion along the length. C bar is nothing but the average cohesion along the length. So, the alpha is nothing but adhesion factor or shear mobilization factor, and C bar is nothing but the average cohesion along the length. Now, let's go back once again. You see this one. What is the average cohesion along the length? Sir, above C1, below C2, average is a C1 plus C2 by 2. No, it's not normal average, it is a weighted average. Because the C1 is there up to that length L1, C2 up to length L2, but I want over a length of total L. Then the average cohesion is weighted average, which is C1 L1 plus C2 L2 plus so on by total length as L. If it is a homogeneous soil, then C and C bar both are same. So do remember, always C is at the cohesion at the pile tip, C bar is nothing but average cohesion along the length. So once we know both, then you can apply whatever the QU is equals to small QBAB plus QSAS, right? Then QU is equals to, in the case of the clay, the QB is CNC and AB. Basically, we take the circular piles only, but sometimes in examination, they can also give you the square pile. So if it is a circular pile, I told you the base area as a pi by 4d square. If it is a square size, let's say A is a side of the square, then area at base is A square. And what is surface area? Perimeter 4A into length L. So basically we take the pile as a circular pile. That's the reason why I am representing the circular areas. And you can also change that into square if they have given that. Now this alpha into C bar into AS. So CNC into AB plus alpha into C bar into AS. There is one equation, very simple equation to find out the ultimate load carrying capacity. Even in GATE 2023, they have asked a 2 marks question from this topic. In GATE 2023, so If you see that question, yeah. You see this question? So there is a gate 2023, set to 2, which is a 2 marks question that appeared. A circular pile of diameter 0.6 meter. That's a circular pile. Length is given as 8 meters. Was constructed in a cohesive soil stratum having the following properties. The bulk unit weight, which is nothing but gamma, 19. Angle of internal friction phi value is given as 0 and cohesion C as 25. The allowable load the pile can carry with a factor of safety of 3. So what they're asking is allowable or safe load. What is that safe load is ultimate load by factor of safety. And given adapt adhesion factor as alpha 1 and bearing capacity factor, this is NC is equals to 9. They themselves has given alpha value 1 and NC value as 9. This was asked in GATE 2023 set 2. You see, it's a direct question. And moreover, has they mentioned it as a anisotropic soil? No. They just gave you the cohesion, which means it's a homogeneous soil. So in the case of the homogeneous soils, cohesion at pile tip and along the length everywhere, the value is equals to same. So now what they're asking is a safe load. You need to find out the ultimate load. The safe load or first ultimate load, that is nothing but CNC into AB plus alpha into C bar into AS, right? Everything they have given clearly. Actually, in GATE examination, they will not give a plausibility of assumption. They will try to give you maximum amount of the information required to solve that question. If they don't mention, then every time you have to take it that as a unity. If they don't mention. But you see, they have given every value, right? Now, as it is a circular pile, I know that CNC into area is pi by 4 d square plus alpha into C bar into pi dl, right? So, as they didn't mention anything regarding to the anisotropic or homogeneity, we have to take it as homogeneous soil. C and C bar both are 25 and adopt 9 NC value as 9 into pi by 4 into the d value 0.6 square plus alpha value, what is alpha value given? 1 into C bar again 25 into pi into 0.6 into what is L value? 8 meters. So what is the ultimate load? Come on, tell me the value. Come on, tell me the value. I need your answers. Good evening, everybody. So, what are the values? Let me know. Good evening. Yeah, you can answer to me this one. So if you solve, you'll be getting this value as ultimate load 440.608 kilonewtons, right? That's ultimate load, and what I'm asking you is, in this question, it's a safe load. So which is ultimate load by factor of safety. And in the given question, the factor of safety is given as a 3. So 440.608 by 3. So the correct answer, is it, well, is that correct? Please let me know. 146.87. Yeah, so the correct answer will be 146.87 kilonewtons, and if you see, so round off to 1 decimal. If I round off to 1 decimal, then the value will be 146.9 kilonewtons. So this is the question. Okay. Yeah. So that's about the answer. If you solve this, there is one question, a very simple question which was asked in a GATE 2023 based on the concept that I have explained now. So my point is about to let you know how to apply this one. Now let's go back once again. So whatever the discussion we have made here, this is for the clay. And same thing in the case of the sands also it can happen in the case of the sands. In the case of the sands, now in the case of the sands, the ultimate load, again, if L is the length of the sand, if L is the length of the sand, and now D is a diameter, again you can see there is a QB and there is a QS, right? So in the case of the sands, whatever the bearing capacity, it is not CNC. You go back, in the case of the clays, CNC is greater than sigma V into NQ, right? So again, CNC plus sigma V bar into sigma V dash into NQ. But in sand, you know C value is equals to 0. Then the bearing capacity goes as sigma V dash into NQ. So bearing capacity goes as sigma V dash into NQ. And what is the sigma V dash, sir? The sigma V dash is nothing but effective vertical stress at pile tip. Effective vertical stress at the pile tip. But what happens in the case of this? What happens in the case of this QU is, in the case of the sands is, there is one effect known as the arching effect. The pile, whatever this pile, the stiffness of this pile is changed. From the top to bottom, the stiffness of the pile is constant. But if you see the surrounding sand, from the top to bottom, the stiffness of sand is not same, because with the depth, the denseness of the sand keep on increases as you go deeper and deeper. So due to the change in the stiffness of the sand and the pile, what it was observed as, whatever the vertical stress that is going to be increases from top to bottom, it increases linearly up to certain depth. and beyond certain depth it is going to become a constant, which means vertical stress below the ground level increases up to certain depth only, and then it remains constant, and whatever the depth that is going to be up to which where the stress becomes the stress varies linearly is known as a critical length of the pile. So that is due to the arching effect. That is due to the arching effect. So due to arching effect, what is the arching effect, sir? That is the difference between the stiffness of the pile and the sand. Due to arching effect, vertical stress varies linearly up to critical length of pile, and this critical length of the pile DC, whatever this DC, this is known as critical length of the pile. Critical length of the pile, and this critical length of the pile that depends upon the denseness of sand. Denseness of the sand. The critical length of the pile depends upon the denseness of the sand. For loose sand it is different, for dense sand it is different, and that critical depth is around 15 to 20 times of the dia of the pile D. 15 to 20 times of the dia of the pile D. Mind you, in the gate examination, don't assume the DC value. Now, if you see from here, what is the vertical stress? What is the vertical stress? So, now suppose if the length of the pile is more than the critical length of the pile, if the length of the pile is more than the critical length of the pile, if there is a water table over here, then up to this point the varies linearly, gamma dash into DC. The value varies linearly, which is nothing but gamma dash into DC, and beyond this point also gamma dash into DC. Gamma dash into DC. So now if you see, in the case of the pile, whenever the length of the pile is more than the critical length, given that if they have mentioned you the critical length of the pile, and if the L is more than the DC, suppose in the question I'll give you the critical length of the dense sand as a 20 times of the dia of the pile. I'll give you the diameter and you have to find out the critical length of the pile. Mind it, if I would have mentioned. So L is greater than DC, then whatever the sigma V dash at the pile tip is nothing but simply gamma dash into DC. Gamma dash into DC. Suppose if the critical length of the pile, is going to be more than the length of the pile, if the critical length of the pile is more than the length of the pile, then if the critical length itself is more, or if the length of the pile is less than DC, or if stress varies linearly up to DC, if L is less than DC, then the vertical stress is simply gamma dash into L. Sir, if they don't mention about the critical length of the pile, then what to do? In one of the previous gate examination in somewhere around 2014 or 15, they asked a question based on the finding the ultimate load carrying capacity in sands. And in that question, the examiner did not mention anything regarding to the critical length of the pile. In gate examination, if they don't mention anything regarding to the critical length of the pile, mind you, assume the stress varies linearly throughout the length of the pile. Assume the stress varies linearly throughout the length of the pile. So, if this point is very important, if critical length of pile is not mentioned, if critical length of pile is not mentioned, then assume vertical stress varies linearly along the entire length. So this is very important point. In the gate examination, if they do give, then only you have to say. Sir, what about in ESE, sir? In ESE, that too mains examination, there you have to assume. In mains examination, while they are giving the design questions and all, they will mention at one point, assume the necessary details. When they say assume necessary details, in engineering services mains examination, that to descriptive examination, so you have to assume somewhere between 15 to 20. Okay. So in that case, the vertical stress is gamma dash into L. Okay, so this is about the QB, and now coming to the QS. And in the case of the QS is nothing but the skin frictional resistance, coefficient of earth pressure into average vertical stress into tan delta. Here also there is a lot of ambiguity. The K value is different for the bored piles, and K value is different for the bored pile, K value is different for the driven piles, where the coefficient K is nothing but coefficient of earth pressure. So this K value in the case of the bored pile, the K value lies between 1 minus sin phi, and it lies between 0.3 to 0.7. It lies between 0.3 to 0.7. And in the case of the driven pile, the K value is between 1 to 2. For loose sand, it is 1. For dense sand, it is 2. Again, don't worry. I'm telling you once again, don't worry. In the question, if they mention it as a sand, they definitely mention in gate examination what is the K value. You don't need to worry and you don't need to assume unnecessarily what is the value. So if you have installed the pile in a bored pile, they'll mention you the phi value. You can find out the K, 1 minus sin phi. Or else they'll give you the K value directly. In the driven pile, K is equals to 1 to 2. And what about the sigma V bar is nothing but average effective vertical stress. Average effective vertical stress. Average effective vertical stress. So sigma V bar is nothing but average effective vertical stress. Average effective vertical stress. Now, what is the average effective vertical stress, sir? The average is from top to DC, the variation look linear, and remaining this length L minus DC, the variation is uniform. So I need to find out the average. In DC length, the average is different. In L minus DC, the average is different, right? So now I have to take both averages. Again, I have to go for the weighted average. So what is the average in a length of DC? Top 0, and this is gamma dash into DC, linear variation, average exactly half. Gamma dash DC by 2, that's the average over length DC. And in L minus DC, what is the average? Everywhere it's the same. So now the sigma V bar is equals to gamma dash into DC by 2 into DC. Up to DC, the variation is linear. And in L minus DC, as the variation is uniform, the average is gamma dash into DC by the total length as L. That's how you need to find out the sigma V bar. And what about the delta? The delta is nothing but pile friction angle. Pile friction angle. Pile friction angle. Generally, for concrete pile, we take delta as 3/4 of angle of internal friction. For concrete pile, the delta as a 3/4 of the pi. And again, here also it depends upon bored pile or a driven pile. Bored pile. In the case of the bored pile, the delta is equals to phi. In bored pile, the delta itself is phi. And in the case of the driven pile, if it is a steel pile, delta is equals to phi. And if it is a concrete pile, delta is equals to 3/4 of the pi. Again, don't worry, they will mention you the delta value. If they don't mention anything, then assume the delta is equals to phi. If they don't mention anything, always assume delta is equals to 5. So, do I need to really stress about this one? No need. Because there are a lot of things, lot of assumptions are happening over here. So, in the case of the sand, it's not simple. It's highly complex, lots of assumptions are there. Without giving the proper data, it is always difficult to solve. So, in gate examination, examiner knows clearly about this point. He will clearly mention the regarding data. They will never ask you the assumed values because gate examination is a so precise examination. In ESE mains, you can go for the assumptions. So overall, the stress that you can find out in the case of the sands. In the case of the sands, you can find out finally QU is equals to QBAB plus QSAS, where QB is sigma V dash into NQ into AB plus K into sigma V bar into tan delta into AS. This is the ultimate load carrying capacity in the case of the sands. And if I ask you the safe load carrying capacity, Q safe is nothing but Q ultimate by factor of safety. Okay, so these are the things that we learned for the individual piles. And if I ask you for the, see, I have given you for the sands and clays. Sir, what if there exists both soils, sir? Suppose, if you see a condition, where I'll explain in this fashion. Suppose, if I give you a condition, above it is a clay and below this is a sand. And if I give you a condition, above it is a sand and below it is a clay, right? So in this case, then there is a combination of soils. The ultimate load carrying capacity, the base resistance is due to the sand, whereas skin friction is nothing but S. So QU is nothing but, what is the base resistance, man? Due to the sands, sigma V bar into NQ into AB plus skin frictional resistance QS, which is nothing but the skin friction of the clay, which is alpha into C bar into AS. So this is the bearing capacity of the sand and this is the skin frictional resistance of the clay. But sir, what is the sigma V bar, sir? Sir, along the length, who is there? Clay. In clay, there is no arching effect. In the case of the clay, the stress varies all along the length. Simply, that is gamma into L. That's it. Where sigma V bar is nothing but gamma into L. If there is a water table, do take it as gamma dash into L. Because in the case of the clay, no arching effect. In the case of the clay, there is no arching effect. Okay. Now similarly in the case of the sands and clay, now if you see the ultimate load carrying capacity, the base resistance is due to clay and skin friction is a QS. Now what is QU? The base resistance is due to clay. Due to clay, what is the value is bearing capacity CNC into area at base plus skin frictional resistance is due to the sand, which is K into sigma V bar into tan delta into AS. But in the case of the sand, as there is an arching effect, the stress varies linearly up to certain depth only. So whatever this depth DC, and mind you, if they do give the DC, then only you have to consider the DC, then gamma into DC, where you need to find out the average effective vertical stress along the length. So no matter whatever it is, I don't want you to remember as a whole equation. If you try to remember, this was a part by part. What is the bearing capacity? What is the skin friction? Then you can understand this topic much more better. So I hope you understood this topic. I hope you understood this topic, right? Now, if you see, but we never we never construct the structure directly on a soil mass. We never construct the structure, we never construct the structure on a single pile, do we? No. We don't construct the structure directly on a single pile. We do construct the structure on a group of piles, right? And if you are going to construct the structure in a group of piles, and what is the ultimate load carrying capacity of the group? So here also I'll be explaining now. Pile group capacity. Pile group capacity or group capacity of the pile. You take any pile group, the minimum number of piles required to form a group is 3. You know, one of the tallest skyscraper as of now, and in the future something will be coming, but as of now the tallest skyscraper is Burj Khalifa. And mind you, the Burj Khalifa is resting on a pile foundation. And there literally 192 piles are installed below that. 192 piles are installed below that, and the depth of the pile is the length of the pile is 50 meters. The length of the pile is 50 meters. 50 meters is equivalent to 17 floors. One floor height is 3 meters. Just imagine if you are standing in front of a 17 floor building, one floor is 3 meters, 17 floors, 51 meters. Then whatever the 17 floor building you see in front of you, imagine that 17 floors existing below the ground level as a foundation. Burj Khalifa, it is 862 meter tall building, and that tall building is resisting and is standing like that because of the foundation that we provided, which is known as a deep foundation, and that's a pile foundation. Total 192 piles were arranged up to a length of 50 meters. So we never construct a structure directly on a single pile. We construct the structure on a group of piles. If you construct a structure on a group of piles, suppose if I take a single pile, now in the plan view, this is a single pile. In the plan view, this is a single pile, and if you see, this is the pile installed. In the case of the single pile, the maximum load that the pile can take, I can say Qi, which is nothing but the ultimate load carrying capacity of the individual pile. So that's what we have discussed so far. If it is a clay or if it is a sand, how to find. But if you are going to take the same pile in a pile group, suppose let's take a pile group of 2 by 2. Now the similar piles, now I am going to arrange in a pile group. This is one pile, this is one pile, this is one pile, this is one pile. And you're going to arrange that in a group, and let's say this is nothing but the pile cap. So the same individual pile, but likewise we are taking the 4 piles over here. This is one single pile and that's a pile group. The length of the pile is same. The dia of the pile is same. The material that we made of the pile is also same. Let's say concrete pile, let's say diameter same, everything is same. But in this I installed only one single pile, and in this a group pile has been installed. So if you see here in the section view, we can observe this is one pile and this is one more pile. On the top of it, whatever, this is nothing but the pile cap. This is a pile cap. But now the entire load carrying capacity of this group, let's take this is a Qg. So Qi is ultimate load taken by the single pile. Qg is ultimate load taken by the pile group. Now my question is, do you think really here there is a one pile Qi? Here how many piles are there? 4 piles. Then if I write down Qi is ultimate load carrying capacity ultimate load carrying capacity of single pile. Ultimate load carrying capacity of the single pile, and QG is nothing but ultimate load carrying capacity of pile group. Ultimate load carrying capacity of the pile group. Okay, so single pile, ultimate load carrying capacity of single pile, and ultimate load carrying capacity of a pile group. Now my question for you, see that example, single pile QI, and there in the pile group, if I say N is total number of piles, N is total number of piles, does QG is, there are 4 number of piles over here, 1 pile ultimate capacity is QI, 4 piles are 4 into QI. Do you think the QG is a 4 into QI? Do you think the QG is a 4 into QI? My question for you, do you think the QG is a 4 into QI? Or less than 4 into QI? Or more than 4 into QI? I'm asking you, please answer to me. Do you think it is going to be 4 into QI? What is a 4 over here? That 4 is nothing but total number of piles. So 1 pile is QI, now there are 4 piles. Sir, 1 pile QI, now 4 piles are there, 4 into QI, then the group capacity is a 4 into QI. Is it going to be? It can be 4 into QI, or it can be less than 4 into QI, or it can be more than 4 into QI. Let's say 1 pile maximum, ultimate, it can take 1000 kilonewtons. 4 piles are there, 1 pile 1000, then 4 piles, the group is 4000. No, it need not be 4000 always. It can be 4000, it can be less than 4000, it can be more than 4000. That depends upon the spacing between the piles, the center to center spacing between the piles, and the type of soil that you are going to install. If the piles are spaced very closely, if the piles are installed very closely, the problem over here is whatever the pressure bulb of the pile, these pressure bulbs may get overlap. If the piles are kept very close, the pressure bulb may overlap. When the pressure bulb overlap, then the capacity of the soil to take the load will be decreases. So 1 pile can take a maximum of 1000 because that 1000 is due to the resistance offered by the soil at the sides and at the base, right? If the piles are so closer, the pressure bulb may overlap, the capacity of the soil decreases. When the capacity of the soil decreases, the resistance offered by the soil is less. Then the group capacity is not 4000, it is less than 4000. Suppose if the soil is a clay, while you're driving the pile, the clay will undergo remolding. Remolding means it gets disturbed. When the pile gets disturbed, for single pile, and this is a group pile, in which case the soil will get disturbed more? If it is a clay soil, center the clay soil, due to the pile driving of a group, the soil gets remolded more, and in the case of the clay, soil loses its strength. Lesser the strength, lesser the capacity, and QG is less. But in the case of the loose sand, if it is a loose sand, in loose sand, due to shearing, interlocking between particles will increase. In case of the loose sand, interlocking between the particles will increase. When the interlocking between particles increase, so initially it was like this, when the interlocking increases, strength of the soil increases. So if this is a clay, due to shearing, it undergoes remolding, strength will decrease. When the strength is less, for 1 capacity QI, for group it is not 4 QI, it is less than 4 QI. If it is a loose sand, strength will increase due to interlocking between the particles increases. So the capacity will be more than 4 times of QI. So whatever the point I want to mention over here is the group carrying capacity, the load carrying capacity of the group, it can be greater, it can be equal, it can be less than N into QI. It depends upon the type of the soil. And in order to know this, we have one term known as a group efficiency. Okay, so Now that group efficiency neta G. What is this group efficiency? The group efficiency is the average load carrying by a single pile in the group, average load carried by the single pile in the group to the ultimate load carried by the single pile. It is average load carrying capacity, average load carrying capacity of single pile in group to ultimate load carrying capacity of single pile. Average load carrying capacity of the single pile. So what is the average load carrying capacity? Total group capacity is QG. 4 piles are there. Then what is the average of each pile? QG by 4. Total is QG. It can be any value, but if I say average, that divided by the N. And you see here, the group efficiency is average, which is QG by N. Average, which is QG by N by QI into 100. QG by N by QI into 100. And if you write down this form properly, then the same thing I can write as neta G is equals to QG by N into QI into 100. QG by N into QI into 100. Now, the average, the group efficiency is nothing but average load carrying capacity of the pile by ultimate load capacity of the pile. Average capacity by ultimate capacity. Now, if I write down this, I already mentioned that based on the type of the soil, the group efficiency, this group efficiency depends on number 1, spacing between the piles. Number 1, spacing between the piles. Number 2, type of soil. Number 3, method of installation. How you are going to install that pile, that's also matter. Method of installation. And that group efficiency, as you know, QG is greater than or less than or equals to N into QI. That group efficiency can be more than 100%, can be less than 100%, can be equals to 100%. For optimum spacing, in the case of the optimum spacing, efficiency of the group is equals to 100%. Optimum spacing matlab, there is no overlapping between the piles. If you see this is a pressure bulb and this is a pressure bulb, if there is no overlapping, each pile will be able to take ultimate load. Each pile will be able to take ultimate load. 4 piles, 4 ultimate loads, 4 into QI. Then QG is 4 into QI. QG is N into QI. Then group efficiency is 100%. And in the case of the dense sands and the clays, the group efficiency is less than 100%, because in dense sands, interlocking between the particles break. In clay undergoes remolding. Whereas in the case of the loose sands, the group efficiency is greater than 100%. Why, sir? In loose sands, due to densification. Interlocking between particles increases. Okay, so this is how you are going to find out the group capacity, group efficiency, but I am not dealing now how to determine the group carrying capacity QG. because in the given stipulated time that we'll be seeing another way, but what I'm trying to do is there is one empirical formula to determine the group efficiency. There is one empirical formula to determine the group efficiency. So the group efficiency is nothing but average load by ultimate load. But for that you require the QG, right? What is QE? QG, ultimate load carrying capacity of the group. Okay. So now I'm not dealing with how to determine the QG. I'm not dealing with how to determine ultimate load carrying capacity of the pile group, but I'm giving you, if you don't know the soil properties, just by knowing the pile dimensions, there is one formula to determine the ultimate load carrying capacity. To determine the group efficiency. So what is that formula? That formula is known as Converse-Labarre formula. Mind you, this formula will be used if soil properties are not known. This is used to determine group efficiency of pile group. This is used to determine the group efficiency of the pile group. It does not depend upon the soil properties. It doesn't depend on soil property. Whether it is a sand, whether it is a clay, it doesn't matter. It all depends upon the spacing between the piles. It all depends upon the spacing between the piles. So if you take any pile group, which is having a m by n, number of piles in the row and number of piles in the column, m by n pile group, and if you know the center to center spacing between the piles and if you know the dia of the piles, the group efficiency is given as 1 minus theta by 90 degrees into m into n minus 1 plus n into m minus 1 by mn. M into n minus 1 plus n into m minus 1 by mn, where m and n, those are the number of piles in the group. That is fixed. And it all depends upon the theta. And what is this theta, sir? The theta is nothing but tan inverse of d by s. If d is the dia of the pile and s is the center to center spacing, if d is the dia of the pile and s is the center to center spacing. So from here I can find out the group efficiency. From here I can find out the group efficiency. Once I know the group efficiency, I can use this formula also to determine the ultimate load carrying capacity of the group. In GATE 2022, again they asked a question based on the same concept. Now we'll see this question. See, I'm not giving the lecture how to determine the ultimate load carrying capacity of the group directly. I'm giving you, if you don't know the soil property, you can use the Converse-Labarre formula. From there you can find out the group efficiency. Okay. So now let's see that question. You see here in this question, so this is the last question that I want to discuss now. So a group of total 16 piles, the total number of piles n are 16 piles, are arranged in a square grid format, square, which means 4 by 5 pile group. So the m by n is nothing but 4 by 4. The center to center spacing between the adjacent piles is 3 meters. Center to center spacing is given as 3 meters. Dia and length of embedment of each pile are 1 meter and 20 meter. Dia of the pile is 1 meter and length of the pile is 20 meters. The design capacity of the each pile is 1000 kilonewtons. The design capacity of the each pile means ultimate capacity of the each pile. The ultimate capacity of the each individual pile, the design maximum capacity, it is known as 1000 kilonewtons. It is known as 1000 kilonewtons. Okay, yeah, 1000 kilonewtons. Okay. Now in the vertical downward direction. So this was asked in GATE 2022 set to 2 marks question. The pile group efficiency is given as, they have given the Converse-Labarre equation. There is nothing but the Converse-Labarre formulae. They gave directly the entire equation, where m and r number of rows and columns, and theta, they gave you the entire equation also for you. The design value of the pile group capacity. Pile group capacity, which means they're asking QG. In the vertical downward direction. In the entire question, has they ever mentioned what is the type of soil? This equation is going to be valid if and only if the soil properties are not mentioned. If and only if the soil properties are not mentioned. If you don't know the soil type, if you don't know the soil properties, then only this formula will be used. Now, they have given the QI, I need to find out the QG. So, what I know is, the group efficiency is QG by N into QI into 100. We have the total number of piles as a 16. We have the individual capacity. But we need to find out the group capacity. How to find out the group capacity? So, how to find out the group capacity? In order to find out the group capacity, I can use the equation as neta G is equals to 1 minus theta by 90 degrees into m into n minus 1 plus n into m minus 1 by mn. And theta is equals to tan inverse of d by s. And what is this theta? The tan inverse of d value is 1 and s is 3 meters. 1 by 3 meters. So the theta value, what is the theta value? Come on, tell me. What is the theta value? What is the theta value? I need your answers. Come on, tell me. So, I need your answers. What is the theta value? You will get some theta value, right? So, let me know the theta value. Tan inverse of 1 by 3, which gives us 18.43 degrees. 18.43 degrees. Okay. So now, if you do substitute over here, then group efficiency is equals to 1 minus 18.43 degrees by 90 into, as it's a square group, 4 by 4, 4 into 4 minus 1 plus 4 into 4 minus 1 by 4 into 4. So, what is the group efficiency? The group efficiency, you will find out. 4 into 3 into 2 by 4 into 4. So, this comes as 0.6928, which means 69.28%. So 69.28%, the group efficiency is 69.28%. Now, once we know this group efficiency, then substitute over here. Then if you know this one, then the group capacity is efficiency into N into QI. What is the efficiency? The efficiency is 0.6928 into total number of piles are 16 piles, and into QI, what is I? 1000. So substitute and you will get it as 11,085.33. So, and they are asking round off to the nearest integer. So if you round off to the nearest integer, that is a 0.33, right? So less than 0.5, you can take it as directly 11,085 kilonewtons. 11,085 kilonewtons, okay? Yeah, so I want you to understand the previous gate questions. So that's the reason why I took a topic that covers these two questions. So this was asked in gate set 2, gate 2022, and this was asked in gate 23 set 2. So if you observe from the past few years, every year in the set 1 and set 2, they're asking you questions from the pile foundations. 2 marks questions or 1 mark questions. These are some of the 2 topics that in the 1 hour I explained you. So in 1 hour, I explained you how to determine the ultimate load carrying capacity of the single pile. In this 1 hour, how to determine the ultimate load carrying capacity of a single pile by means of static formulae in the case of the clays and in the case of the sands. What are the important points that you need to understand during the examination? In gate examination, you don't need to assume anything. Everything they will be giving you. And I have written those points over here, what you need to do if they don't mention those points. And we got to know in the case of the pile group capacity, always the group capacity need not be same as N into Qi. It can be more, it can be less. That depends upon the type of the soil, type of the spacing, and how you are going to drive the pile also. And if they don't mention you the soil properties, how to determine the group carrying capacity by means of the Converse-Labarre formula. That's one of the empirical relation. And don't use this one if they give you the soil property. If they don't mention you the soil property, then only you have to use this equation to determine the group capacity. If soil is given, then to find out the group capacity, there is a other way. That is to find out the single mode failure, block mode failure. You need to find out those and you need to get down what is the smallest value of those two. That is not going to be completed in a given session, that we can see in a separate session. So, and based on this, we discussed about 2 previous gate questions. That's all with this session. So, hope you understood this session and it will be useful for your examination also. And if you have any doubts, you know how to contact us. So you can either ask the questions in the comment section or you can contact us through our online modes as a fresh chat mode is there, or you can write an email to the official mail ID of the ESE Engineering Academy. So once again, this is Pavan Kumar and I'm logging off. Hope you're doing well for your GATE examination and I wish you all the best for your GATE examination. Thank you.